Today we're going to continue our discussion on multiple linear regression. And by way of review, we said that multiple linear regression seeks to describe your variable of interest, which is oftentimes called your dependent variable or response variable. And we would like to explain this variable. We're interested in using other variables, which we call our independent variable or explanatory variable or covariates. Many names are given to this. And we said that your observed value, y sub I, is equal to your model value. We said that this is our predicted value, this one. This is our predicted value. Predicted value because we're using the parameters beta null, beta 1, beta 2, etc. that we derive using ordinary least squares, okay, which is the method used in multiple linear regression, okay, least squares method. And the two are equal if we represent this by y hat. Y hat is your predicted value. It means your predicted value is equal to this predicted model, okay? But if we're going to, let me remove this. Okay, sorry. This one, okay, let me remove this, okay? And let me write here again. Okay, y sub I will be equal to your predicted value. So this is your observed value this time. Observed value, actual value is equal to your model value or your predicted value plus a certain error term. Okay, why is that? Because your model will not really be able to capture, unless it's a perfect model, your model will not be able to capture exactly your observed value. So any deviance, any deviation between your actual value, your observed value, and your predicted value is called your residual. Okay, so your actual value, your observed value, is equal to your predicted value plus your residual. Okay, so we can say that this is your y hat, right? This is your predicted value. So your observed value y sub I is equal to your predicted value y hat, okay, plus a certain residual error term. Okay, and your error term can be written as epsilon sub I, epsilon sub I is equal to your actual value, your observed value, minus your predicted value. Okay, and this is very important because, okay, last time we said multiple linear regression follows certain assumptions. And one of the assumption is that the expected value, okay, expected value of your epsilon of your errors, given your x's, given your x, the ones that you use for your model, is equal to 0. Or this can be written as the mean is equal to 0. So we know that if you add all the residuals of the generated by your data, okay, which is just compare your observed value and your predicted value, you add the residuals, you'll get 0. Okay, now what's the importance of these residuals? The residuals is used in the determination of your betas, of your parameters. So how does that go? We said that there's only one multiple linear regression model. For a given data set, you only have one unique linear regression model. You cannot have more than one. And how is that model determined? When I say model, it means the values for beta null, beta 1, beta 2, etc., the values for your parameters. Okay, and that's obtained by minimizing, okay, the sum of your residuals squared. Okay, so we don't use the sum of your residuals because the sum of your residuals will be equal to 0. Okay, so in modeling, you use instead your residual squared. And that's where the method, the name of the method, uh, comes from. Ordinary least, 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 the minimum squares, the squares of the residuals. Okay, so I think I showed this to you via a diagram, okay, via an illustration. So let's move on and uh, okay, let's go now here. Okay, so we learned how to load packages. So once again, let's make sure that our packages, our load will be using tidyverse, uh, not yet OLSRR, but let's just load all of this. Okay, we loaded this last time. Control Enter. So that will now load these packages. Okay. Okay, may I know, class, if you're done? Kindly chat, please, if you're done, so that I know when to begin. Thank you, Sophia. Okay, thank you, Laika. Let's wait for your classmates. Okay, good. All right, thank you so much. Okay, I hope the others are following along. Okay, last time I also asked you to download the wage dataset. Here. Kindly check if it's in your files. If not, I uploaded it in Canvas. Kindly download that from Canvas and save it into your R project. Okay. Now here is one advantage of here is one good advantage of using R projects. In your R projects, you can identify your you can load your data files, and then you can easily access it. So if you take a look at this code, this command, we're creating an object called wage. Okay? And we're using a function called read underscore CSV. Read underscore CSV comes from the readr package. Okay, let's just take a look at that. And the readr package is actually it comes packaged or combined with tidyverse here. Okay, read rectangular text data. If I click this, so there are many codes here. Okay, one of which is read underscore CSV. And it reads a delimited file including CSV and table separated values into a table. Now, if you watch the videos that I told you to watch, you would have met the term table. Okay, so I will not go into that discussion, but it's a special type of data frame. All right, so let's write this code. I'm putting a name to the name of this code chunk. Make it a habit to do that, class. If you're opening a code chunk, it's good to give a name to your code chunk. So we're creating this object wage using read underscore CSV, and you just identify the file wage.csv. Now that's the advantage, class. One of the advantage of using our project, you don't need to identify the file location of wage.csv. Had we used just an ordinary RMD file, we would have identified the location. Where is this wage that's CSV? In our case, since we're using an R project, for as long as your data is loaded into your R project, okay, just identify the file name here, quotes wage.csv, and then the syntax calls for, we identify that there are column names to this. Column names is equal to true. Okay. I don't have any object here in my environment. If I run this, how do you run this code? Again, several ways. You can highlight the code and then control enter, or you can just click this one, run current code chunk. Run current code chunk will run any code inside this code chunk. Or you can go here, okay, run a selected line. So for example, I'm in this line, it will run this line. But since this line is connected to this line, then it will run this whole two lines. Run current chunk will run every code inside this code chunk. Okay, so there are other options in this here. Okay. All right. So let's just run this current code chunk, and you'll notice that there will appear here, not under values, but under data, wage. And it contains 526 rows of observation and 8 variables. Okay, and it gives us here some metadata or information about the data. 526 rows, 8 columns, and it's a comma delimiter. That's why it's called a CSV, comma separated value. And then there are 3 character variables here and 5 numerical variables, in particular double. So which means they're not integers. They are the numbers that can take on decimal places, namely education, experience, tenure, number of dependents, and hourly wage. Okay, so this is our metadata. But of course, we can take a look more at the data by either typing wage. Let me minimize it. Okay. I'll just clean this first. I'm sorry. Oh no, what happened? Okay, here. Okay, so either I type view wage or I just click this. I access this here, and automatically the code for clicking this is view wage. And what do you find? You have 526 entries and 8 columns, the columns being education, experience, tenure, etc. The metadata tells us that there are 3 character variables: race, gender, civil status, and 5 double or 5 numerical variables: education, experience, tenure, number of dependents, and hourly wage. Okay, so the objective here is for us to be able to explain hourly wage or model hourly wage using all these predictors, okay, all these 7 predictors. And there's a way to do that. But before we do that, let's first examine the data. So I have here some codes. We already did this. We already viewed it. Okay. Okay, maybe we can name this wage data. Okay, so we already did view. And how about class? What does class give us? Class tells us what kind of data, the structure of this data is. So it's a data frame. Okay. And once again, let me remind you to please watch the data and data structures to have a deeper discussion there. So it's a data frame or table data frame. Okay, some nomenclatures about data frame. All right, so that's the class of this object. And then we learned before this one, structure. What does the structure give us? Control Enter to run that specific code. And the structure class gives us a say a more comprehensive metadata. Metadata means data about the data. So this is the description of the data. It's a special table. Okay. A special table is also called a table. A data frame comes in different names. The dimension is 526 by 8, 526 rows and 8 variables, 8 columns, I mean. Then you have here dollar class. Dollar means the dollar here indicates that this is coming from this data, this object wage, dollar education. And this has a special meaning because, you don't find education here in your environment, right? Education is a variable inside wage. So if you want to access that specific variable, education, you will have to go through the wage data set. And to go through the wage data set, you use wage dollar education. So that's what that means. Okay. The dollar there is let's say, it's a way by which you can access that specific variable. Let me just illustrate that. Okay. So if I want to get the average of wage, for example, here, let's get the average of wage. Let me delete this. I want to get the mean of wage. Okay. Can you do that, please? Can you tell me what happens if you perform a statistical process like mean, standard deviation? Okay, what will happen if you try to get the mean or standard deviation or variance of wage? Can you tell me, please, what's the result of this one? Kindly chat, please. What happens if you get the average of wage? Or for that matter, experience or tenure? Would you kindly chat, please? What result are you getting? NA, okay, Sophia, thank you. For Sophia, it says NA. How about the others? Low class. What about the others, please? Sophia also, NA, thank you. How many are we here? We're 22, 21. Okay, so I hope I get responses from, if not all, almost all. Okay, good. Good, thank you. All right, let's give a few more seconds to the others. I didn't even get a 50% participation, and thank you. Salamat, class. Thank you so much. Okay. All right. Merci beaucoup, as in French. Okay. Merci. All right. So now, why is that so? Why is there an NA answer there? Because R does not recognize wage. Wage, as we know, is part of your, sorry, R does not recognize, sorry, it's not wage that I want to get. Sorry, class, it's education. Okay. Apologies, class. Mean of education. Okay, average of education, class, will return an error term. Error, educ not found. It's not in your environment because educ is a variable under the wage data set. Therefore, to access this education, you have to go to min, and then if I type wage and then press dollar sign, there you go, class. That's what the dollar here meant, okay? The dollar here. It means that in order for us to access these variables, tenure, experience, we will have to use the dollar sign and then access education. Now try that, class. Tell me if this one this time if it works. Were you able to get the wage of education? Okay, good. Thank you. Others, please. Right, good. Thank you so much, class. That's great. So, okay, I hope you understand what this means. No? In order for you to access a particular variable in a data set, then you'll have to go through the object where that is coming from. Now, of course, if do I want, can I also create an object called education? You can, of course. And how do you do that? How do you now create an object called education? Okay, well, that's very easy. Okay, you can, let's say, I want to create education alt minus, okay, and then wage. I'm getting this from wage, and then brackets, and then one. Now, what does that mean? The brackets here signify a subsetting. So if I'm going to subset from wage the first row, okay, the first row, or you can put it this way, okay. This is the more proper way to do it. Okay, this class. Because wage is a data frame, which means it contains X rows and Y columns. It's a data frame. It's a rectangular matrix form representation of your data, having individual rows and columns denoted by the name of the variables. So I want wage to be subsetted. Okay, get the first one refers to your rows. If I don't put anything in the rows section, then it means get all the rows. So it means get all the observations, all 526 of it. Okay. Or if you want, we can put here 1 up to 526. So that means for the rows, everything. Okay. Everything. not 526. Okay. Because if I put 526, I'm only going to get the 526 row. Okay. And this one, so let's illustrate that. This one will be the first column. Okay. So if I run this, control enter, see what happens. Education contains only, okay, here, only one row and one column. Why is that so? Because you said that I'm going to subset the 526th, okay, the last row, which is 14. And what column? The first column. So that will be row 526 and column 1. So that will be only one element. Okay. And the right thing to do is education. Educ, okay, alt minus, wage, okay, square brackets, and then leave the row blank, and then 1. Leaving the row or the column for that matter blank means get everything. Or as I said a while ago, put 1 up to 526. So if I run this, there you go. We now have education containing 526 observations and 1 row. Now we can get now the mean of education. Okay, you can do that, which is, oops, sorry. What happened? Uh, mean of, okay, mean of, okay, all right. So this is something tricky, okay? So education is an object, okay? Mean of education, and then what we want is that variable there, education, okay? So this is something tricky. Okay, but of course, as I said, what's the purpose of getting the average of education by creating the education variable itself, okay, when you can directly get it from the wage object. So I hope, class, that that makes sense. Let me pause for a while because I might have confused about it. So let me give you a chance to ask yourself or to confirm that you got what I was saying. Okay, I hope I was not going too fast. Okay, attendance later na. Okay, any questions about that, class? About getting the average or getting, for that matter, any statistical metric of any of any variable? Okay, you have to go through the object itself. There's another way, but I'll discuss that later. All right. May I have your confirmation, please? If you got what I was saying, I might have been going too fast in explaining it. Confirmation, please, class. May I have your feedback? Questions, please. By the way, on Monday, I'll be seeing you finally, and I apologize for the missed face-to-face classes. I'll, although my wound is not still not that, but I can already manage to travel. Okay, no questions. Okay, thank you, thank you. Okay, let's move on. Okay, so we run the structure. Okay, let me put this here. Summary we did before. Summary we said will compute for the first, second, third quartile, the minimum, the maximum, and the average. It will do that for all the variables in your object. Let's do that for wage. And you can see here that it computed for the minimum, maximum, first quartile, second quartile, third quartile, and the average for all your, okay, quantitative variables. So wait, education, experience, tenure, here. I thought I was missing results. Okay, so there are 5 quantitative variables and there are 3 categorical variables. Of course, the categorical variables, you cannot compute for the mean, median, because first quartile, second quartile, because they're not numeric. So what happens with the categorical variable is there's just a count. It's just a count of uh, how many are uh, in that variable. 526. Okay. Now there are other packages that give us give us more information. dplyr has a very good uh, function called glimpse. So let's just use the dplyr package. You don't have to you don't have to load this because remember when you loaded tidyverse, dplyr is already loaded with it. So if you check your packages and we didn't actually load dplyr, right? None here. But if you check your dplyr, okay, it's clicked, it's loaded because it comes with tidyverse. All right. Okay, so dplyr, we're going to make use of the glimpse function here. And let's run this and see. Control enter. There. It's similar to your structure. Okay. Similar to your structure. Okay, so it tells us rows and columns and then the type of variable inside this wage dataset. Double, double, double character. So five numeric, and three character variables. So that's the glimpse glimpse function. Now, sometimes you might want to see the distribution, the cross tabulation. Okay, so I just want to see in our categorical variables we have race. Okay, if you recall, for the summary of wage, you can see here that it didn't tell us what are the levels or what are the different elements of your character variables. That can be seen here. We can make use of the table function. Okay. So table, the race variable, the gender variable, and the civil status variable. And as I said, we have to course it through the wage object. If we run this, control enter, then it gives us a distribution of how many non-white. So for race, there are two levels, non-white and white, 54 non-white and 472 white. There are 252 females and 274 males. 320 are married and 206 are single. Okay, once again, I'm going to pause and ask you if you are able to follow along. So far, the glimpse and the table. Okay, I have to give you time because I didn't give you this code. Most of the codes class, I want you to write it for practice. By the way, you notice that I can write codes in one line, different codes, just separated by a semicolon. Okay. By the way, last time, uh, I got confused. So I dismissed you at 12:16. I thought we were only up to 12:15. So that's why I said, why is the log quite long? I was waiting for the other class at 12:30, and then I realized that it's our class is 12:45. So this time if I make that mistake, class, please remind me. Okay, I get confused sometimes with the time. All right, so no confirmation from you, class, if you were able to get this, the table function. All right, good. Thank you. Waiting for the others. All right. Okay. Now, let's take a look at this, class. So far, we have learned how to create uh, some descriptive statistics using the summary function. There are many other packages that can provide us with that result. For example, first one is from the psych package, okay, you have the describe function, describe and wage, and what do you get? So we have 13 columns uh, 13 columns including the title, the variance, the variables, the number, the average. Okay. Now, if you notice here, it gives us an average and a standard deviation and median for those categorical variables. Of course, they don't mean a thing. What happened there is that they assign the number one to a level and then zero to another level. And then since they're now converted into ones and zeros, then they just get the average of that or the standard deviation of that. So it does not mean anything here. So nothing, nothing of relevance there as far as the mean, standard deviation, or for that matter, all the metrics for the categorical variables. But for the quantitative variables, they are important. So the average, standard deviation, second quartile, trim median, mean absolute deviation, minimum. Okay, so there's maximum, there's range, which is just the highest minus lowest value, skewness and kurtosis and standard error. So there are 13 columns here. Okay, and if may I request you to please review those basic statistics measures like range, skewness, kurtosis, those measures of central tendency. Okay, so we won't discuss that here. Okay. Aside from the describe, aside from the describe function, there's also this other package called HMISC, okay, which also uses describe. And let's see what this gives us. So if you take a look at this one, 8 variables of 500, no. So we take a look at this via per each variable. So a wage and then education. Okay, education, and then there are some measures here. Hold the line, please. Okay, so you have here education and 526. Okay, missing 0, distinct values 18, information, mean, okay, I will have to check class. Then you have value, frequency, proportion. Okay, we will have, you can check what this, what these values mean, okay? GMD, I'm sorry, I forgot what this means. I'm not sure if it's mode or whatever. And then these are the values, okay? These are the values of the data. For example, how many zeros? 2. How many 2? There are 1. So it's just a frequency count, okay? How many 18? There are 19. How many 12? There are 298. And it gives us the proportion. Okay. The biggest, so this would be the mode class. The biggest occurrence is 12 years of education, 198 all in all, and they account for 37%, around 38%. Okay, so the same thing for all. except of course for the categorical variables. So HMISC has also pretty uh, comprehensive computation, descriptive statistics computation of your data. All right. Then you can also use from site, not only described by. Okay, so in described by, we identify the object and then the particular variable. Okay, site described by, uh, use the object wage and then the particular character variable. Okay, if we run this, okay, let me see. All right, so this is more the descriptive statistics by group. Okay, so it's breaking down your descriptive statistics by grouping. So there are female and there are male, and it gives us the metrics, okay, for male and for female. Okay, so it it into the number of levels of your of the variable that you're interested in. So of course this will be true more for categorical variables. You can also check race and it will give you the same thing. Okay, and we also have the package scheme-R, and we have this function scheme. And how does this work? If I run this, so almost the same as the described, uh, missing values, percentage of completion. So if there are no missing values, this is 1 or 100%. Then you have the mean, standard deviation, mean, standard deviation, and then this is the minimum value, first quartile, okay, second quartile, third quartile, maximum value, and then you have your a histogram, a plot of the variable. So you have here a mini plot of the variable, which may come in handy for you to appreciate or understand how the variable is behaving. Okay, let me pause for a while and allow you to copy or follow along. And if you're done, class, kindly chat yes, please. Up to scheme-R package. Thank you. All right. So you can see here, class, advantage of putting the name, what do you call it? Namesake, okay? Where that function scheme is coming from. This is coming from the scheme-R package. All right, a few more. Also from the desk tools, you have desk. You can get, we can get wage, hourly wage. Okay, so this is really complete. So what does this give us, class? Hourly wage. It's more of the distribution. Gives us the range. Okay. Unfortunately, it's the spacing is not that good. length 526, and the same as length 526, missing values, unique values, how many zeros are there, the mean, the 100%, 0%, I'm not sure, but maybe this is the maximum or minimum. Okay, I'll have to check. We have to check class the syntax of scheme R. No, I of desk from desk tools. And then here you can see a plot of your hourly wage. Okay, then you can do that for a for the whole object. So if you do that for the whole object, then it will one by one, all the variables, it will create a descriptive statistics of all the variables. Okay, that's why you have several pages here. So this is for education and for the other variables also. Okay. All right. So moving on. Okay. Uh, let me remove this first. Okay, we already discussed part of this. So if I'm going to plot hourly wage, this will not work because hourly wage is found inside wage data. Okay, so R will not understand what hourly wage is. Okay, so error, hourly wage not found. Okay, but we can do this plot and then wage and then dollar, right? There you go. Plot wage and then dollar hourly wage, and then it will give us a plot, scatter plot of the object hourly wage. Or you can do it this way. How about writing plot, and then what do you want to plot? And then this one class. Plot. So here we're plotting two variables, education and hourly wage. Okay. And we're giving a title to the main the title of the main plot, main title. And then if we run this again, it will return an error term because R does not recognize does not recognize education and hourly wage. So either you plot again access wage dollar educ comma wage dollar hourly wage. Okay, of course you can copy the main is equal to okay. How about this? Will that work? Feedback, please. The first variable there will be the x-axis, and the second variable will be the y-axis. That's default. Waiting for your feedback, class. You get it, class? How about some questions or some clarifications or some confirmation that you were able to get it? Thank you. Thank you, Michael. Danica, thank you. Sophia, okay. James, Michael, thank you. I hope the others are able to follow along. Okay, good. Okay, thank you so much, class. So you can plot in an XY scatter plot, class. You have to identify the two variables. Okay. But is it possible to do this? Is it possible to control alt I? Let's create a new code chunk. Is it possible to get the mean of hourly wage? We know that this cannot be done because R does not recognize hourly wage. So this can be done by first using the attach function. Okay, there. The attach function will inform R that uh, anything after this, anything after this line of code, any command after that will refer to the wage data set. Okay. So by attaching, R now understands, oops. So we're now using the wage data set. And to get the mean of the hourly wage, it's contextualized now as belonging to wage data set. Okay. Instead of using wage dollar, you can do attach and then run this. You can show that the mean is of hourly wage is 5.89. Okay, and then we can also plot, let's say, plot education. There you go. Okay, so by using the attach function, now, oftentimes you'll be working with several objects, and there might be a confusion when you'd like to use another object while your wage data set is still attached. So if you're going to use another data set, another object, make sure to detach your wage data set so that there will be no confusion. Okay. Detach wage, and it's the same as here, plus, it's the same as detach. And then if I once again get the mean of education, okay, it will once again render an error term because education once again is not recognized because wage has been detached from memory. Okay, plus, once again, I'd like to seek your, are we okay with the attach and detach? Attach, detach. When is this advisable to be used? If you're going to work on a particular object, let's say only one object for your full RMD file, then it's advisable to use attach because anyway, you're only dealing or working with one object. But if you're working with several objects, what you can do is if you're in that portion where you're just going to use wage for the next command lines, next codes, then perhaps it's good to attach. Okay, but later on, once you're done with it, it's best to detach it. Okay, so let's move forward and let's take a look at here. We discussed this a while ago about subsetting, about creating a new object containing subsets from from your object. Okay. So we're going to compute for, let's say, let's use the function correlation of wage. Oops, sorry, not core, but single R core. Oh, sorry. Yeah. So we cannot use the function core because we have objects in wage that are it's double R. Let's check. Am I right? The intelligence. Single R. There's a single R, and I think there's also a double R. Single R. Correlation. All right. Now we cannot do this because you have you have objects that are categorical. Okay, and we cannot get the correlation of a numeric and a categorical variable or a categorical and a categorical variable. So what we'll have to do is, if you take a look at our wage data set, okay, so let's run this first. This one. Go here and let's use GG pairs wage. GG pairs. So this is from Grammar of Graphics. Let's see what happens. Control Enter. Why? Sorry. We have to install, okay. There's a function, there's a package called GG Ally. Apologies, class. Let's install GG Ally first. GG Ally. I have it in my case, okay. In yours, you don't have it. So please install GG Ally. Okay, GG Ally here. GG Ally. A-L-Y. Okay, here. Okay, it's an extension to ggplot2. ggplot2 is a very powerful data visualization package. So if I load this and then I see GG pairs wage. Okay, take a look at this correlation plot. Where's that? Okay. Did it run? Not yet. Okay. There, class. So take a look at this. Let me maximize it. Did not. Okay, I'll just use this. Okay, so you have a quite a rich depiction. It's a scatter plot between education and education. Okay. This is education. This is, for example, race. You notice that for race, you have a distribution. Okay, race. This is white, non-white, etc. Okay, and on the upper part, you'll have correlation here. So, for example, the correlation between experience and education is negative 0.3. Okay, that's the correlation. The correlation between tenure and education is negative 0.056. Okay, the correlation between education and hourly wage, okay, education and hourly wage here, education hourly wage is 0.406. So as far as the data is concerned, on the okay, as regards the dependent variable, its correlation with education is 0.40, with experience is 0.30, 11, etc. With number of dependents is negative 0.05. So based on this class, the best predictor based on the correlation between the dependent variable hourly wage will be your education. Okay, just based on that, because it has the highest correlation. And we want your dependent variable to be highly correlated with your independent variable. On the other hand, if you take a look at this tenure and experience, tenure experience, 0.5, okay, relatively it has a high correlation, even higher than the correlation between hourly wage and education. It's 0.5. Okay. So we said last time that we don't want to have that kind of a thing called multicollinearity, where your independent variable, tenure in this case, and experience are highly correlated. Okay. We don't want a situation like that because they will it will be quite challenging or difficult to disentangle the contribution, each of the variables contribution in explaining the variability of your dependent variable. All right. So you can see here that race, gender, and civil status, this has no meaning as far as correlation is concerned. So what we're going to do here is we're going to create an object and delete your race, gender, civil status, your fourth, fifth, and sixth variable. So how do we do that? We learned this a while ago. So here I'm creating an object called wage one, and it's from the wage data set, subsetting. So we're going to include all your observations. And then minus C, 4 to 6. Combine, negative here means not, okay, not including 4 to 6. So it's 4, 5, 6. Race, gender, and civil status. So we want to remove that. Okay. So let's do this. Let's first run this and create the wage one data set. We will now have here in our environment, we will now have wage one. So if I run this, control enter, notice now that I have wage one. And wage one has the same number of rows. However, there are only five. There are only five variables. Okay, because we remove three of them. So if we check wage one, we check it. So we only have now five variables. Okay, we have education, experience. The three categorical variables have been removed. Okay, no more race, no more gender, no more civil status. So we can now create, we can use, we didn't use this a while ago, no? But in pairs, in the site package, there's a pairs.panels. let's use, let's do it, let's do this, Control X, let's put it here. Let me just fix my, okay, Control V. So let's use this GGLI. Good to put the package from where it's coming from. Site package, pairs.panels, wage, control enter. All right, quite similar to GGLI. Okay, where's that? Here, class. You can see here the this is the scatter plot together with the histogram. Okay, this is the scatter plot of education with, so this is education with experience. This one, scatter plot education with here. Okay, sorry, education experience, this one. Education with tenure, this one. Just have to go identify the variable, this column, and then pair it, identify the row it's coming from. It's being paired with. And on the upper side are your correlations. Okay. If you take a look at this race together with tenure, negative 0.01, but that has no meaning because race is a categorical variable. So we don't actually have a correlation between a categorical variable and a numeric variable. Okay, so let's apply that here, class. Okay, let's use psych pairs.panels, control enter. And you can now see that it only gives us the quantitative variables, numerical variables. So this is the plot of education. This is the plot of experience, tenure, number of dependents, and hourly wage. Of these five, education is the closest to a normally distributed a variable. Then over the top here are your correlations. So how this is of particular interest to us because this is your this is your dependent variable. So of all our predictors, education has the highest correlation with hourly wage. We said that in multiple linear regression, we want the variables to be the dependent and the independent variable to be highly correlated. Here you can see the correlation between hourly wage and your quantitative predictors. Education seems to be the most the best among the four among the four to describe hourly wage by virtue of having the highest correlation. What comes next is tenure having 0.45 and experience 0.11. The least related to hourly wage is number of dependents. Okay, so we can use that a function. Sorry. Where are we? Here. Or also we can use since we're already loaded GG ally, we can use GG pairs for wage one. Control enter. And same thing as above. But this time, no categorical variables. Okay, there. The advantage here is that it's a lot cleaner than the pairs.panel. And you can see here that you also have the if the correlation is statistically significant. A 3 stars here means that it's significant at 0.05. Okay, there are some correlations that are not significant. For example, tenure and education, their correlation is not significant. Okay. Okay, so let's first start with we have time now to have an introduction about simple linear regression. Okay, and we make use of the function LM. LM stands for linear model. So let's make use of this. Okay, let's first run this class. I want you to create this code chunk. Call it simple. Let's call it simple regression. Okay, so what are we doing here? The LM function is a very powerful function class. It's linear modeling. That's all we need in order to develop a regression model between your dependent and independent variables. So LM, then here is your dependent variable. Remember, we're modeling hourly wage. And then tilde, okay, tilde stands for is associated with, okay, and you can find tilde, where's your tilde class? in your keyboard. It's on the upper left, right? Upper left above. It depends on your keyboard, but in my case, it's above the tab button. All right. So we're regressing. We're going to use first a simple regression where you only have one variable, okay, one predictor. And since based on the correlation, okay, correlation plot, education seems to have the highest correlation, then we make use of education as the primary predictor. So the syntax is LM and then identify your dependent variable tilde independent variable. So if you're going to add another variable, let's say experience, this is how you do it. Education plus experience. Okay. But let's not do that now. Let's just focus on education and then identify the data. The data is equal to wage. Okay. Data is equal to wage. All right. So we can run this now. Control Enter. And you can see the object that was created is here, plus. Okay. The object created is mod1. And it's a list of 12. Okay. A list is different from a vector. A list is different from a data frame. The difference between a vector and a list is that a vector can only take in one type of data. So you have a vector of characters, you have a vector of integers, you have a vector of logical values, you have a vector of numbers. On the other hand, a list may contain all types of data. And if we click this class, okay, here's what's inside mod 1. Okay. All right, we'll have more time to look at this. Notice here, coefficients. This is the value already of your model. Okay. This is coefficients. So this is your intercept, and this is your slope for education. Residuals class. Okay. Residuals. Fitted values are also here. And so have tons of relevant information here about your model. We'll take a look at this in greater detail as we move on. I just want to show this class. Okay. So what are the names? The names of mod 1 or model 1. Okay. If you run this, okay, it contains all that's inside your mod 1, which is this one. Okay. Coefficients, residuals, etc. Okay. So this is a list, mod 1. And you can access, for example, mod 1, coefficients is under mod 1. So I'll type mod 1 dollar. Okay. And you can find here all that's inside, all that's inside your mod 1. So if I choose arrow down, coefficients, tab, okay, control enter, then there you go. It gives you the coefficients of your model 1. Okay, so you have your intercept and your parameter, your slope for education. Okay, so these are the elements of model 1. In fact, another example, mod 1 dollar, then residuals. There you go, control enter. There. So these are all the residuals. Remember that the residuals is the difference between your value and your observed value and your predicted value. Okay, class, it's almost time. My watch is a bit advanced by, I think, 1 minute. So let me just end in here, class. The summary model 1. Okay, this is very important. Control enter. And we'll stop here and we'll discuss this in greater detail. Suffice it to say, class, that this one is the main, let's say, the core of the result of mod 1. So it gives us, call means the formula that we use. It gives us the distribution of the residuals, gives us the coefficient. This is the intercept. This is the slope for education. It gives us the standard error of each parameters, a t-value, p-value, and the intercept. Okay, and we have here what's the meaning of 3 stars? Education is 3 stars, so it's significant at 0.001 level. Then you have here also some important statistical information. Okay, so let me stop there, class. And next meeting, we're going to carry on from here and go to discuss this, okay? Some mathematical discussions, and then go to multiple linear regression. We're going to use now all the predictors. Here we only used one, education, and the reason for that is education is the one that's highest, that has the highest correlation with our dependent variable hourly wage. Okay, so let me